Hello, in this video I would like to give a high-level walkthrough of my final year project. My FYP is about smart contract analysis and verification. In this project, a property checking tool for Solidity called Solve is developed. What is Solve? It is a property checking tool for smart contracts written in the Solidity language. Solidity is one of the most popular language for Ethereum smart contract development. It looks kind of like JavaScript. Also, Solve is a command line tool. What sets Solve apart from other analysis tools for Solidity is that it allows users to declare properties that a contract is expected to satisfy in the source file. More on this in the next section and the demo. How does Solve work? The user has to declare property as special comments. As shown in figure 1, declarations take form of special comments. In this example, the variable declaration node is declared to be fixed after initialization. It's abbreviated into like fixed after init here. So the special comments start with double slashes as usual, and add verifier, and then the property name, in this case, is fixed after init. Right. Once we have the source file ready, we can invoke solve from command line, like in figure 2, just calling solve executable using pass to source files as argument. After that, solve does some work internally, and then it reports the results to the console. Right. As well, there's an example in figure 2 as well. But what actually happens internally in Solve? First, it parses and analyzes the source file to get the AST as shown here in the sequence diagram, and it actually uses this component in Solidity language called compiler stack. So compiler stack is usable because this project is built as part of Solidity compiler project. Right. And second, it creates property checking tasks for each special comment found in the source file. This is done using the factory pattern. So as you can see, the task factory is here. Also, we use task locator to obtain target AST node. So if you look at the example in figure 1, the target AST node would be actually this variable declaration node. Right. So at the end, each property checking task is executed, and any violation of properties found will be reported to a standard output. Property checking is done primarily using visitor pattern. Also, this is done also by reusing components that are already in the Solidity language, and specifically in the lib Solidity. Okay, so without further ado, let's move on to the demo. Okay, so let's start with the source file, contract.so. It's a very simple toy example. So it's got a constructor here that only calls this private function set owner, and the set owner only sets a state variable owner to the sender of the message. This contract is useless indeed, as there is nothing in its public interface. That is, there's nothing other contracts can call in it. But it is sure that the state variable owner wouldn't be able to be modified after contract construction, so owner should satisfy fixed after init, right? So let's just try using solve with this contract. So quit vim, right, and do solve contract.solve. It's saying that no property is declared. Well, obviously, if you go back to the contract, indeed there's no property definition. What can we do? Let's go ahead and add another definition then. We'll do add verifier fixed after init, right? And now we have a proper property definition, and let's try again with solve, right? Now it's saying that no violation of property is found, and this is as expected because because if you go back to the contract, well, indeed, there's no way to change owner after the constructor has been run, right? So why not let's do something to violate the property that we just declared. Say let's adding this function. We just call it some public function, and it's public. What it does exactly the same thing as a constructor. Well, this is a toy example again. This is a toy example, so we just want to violate the property somehow. Okay, and now obviously it's violated because some other contract can call this some public function to change the owner, right? And basically, it can set the owner to anybody it likes. Right. Then let's try again with solve. We're now saying that the function set owner, which contains an assignment to the fixed after init variable owner, can be invoked through a public function, some public func. And if you go back to the contract, is indeed the case, right? And this is as expected. Well, this will be the end of the video. I thank you for your time.